Lesson 3 of our Module 2 is Statically Indeterminate Members. So when the reactive forces or internal resisting force over a cross-section exceed the number of independent equations of equilibrium, the structure is called statically indeterminate. And na-tackle na natin to previously. These cases require the use of additional relations that depend on the elastic deformation of the member. Kasi if you have here a bar S, if we are going to summate force as vertical is equal to 0, so may isa na tayong equation. Hindi tayo pwedeng mag-summate ng moment, hindi tayo pwedeng mag-summate ng forces horizontal kung yung forces natin is vertical. So if that is the case, we will use the formula of the elastic deformation, and that would be the axial deformation in this case. So let's have an example on that. Problem number 1, a steel bar 50 mm diameter and 2 meter long is surrounded by a shell of cast iron 5 mm thick. Compute the load that will compress the combined bar, a total of 0.8 mm in length of 2 meters. For steel, the modulus of elasticity is 200 gigapascal, and for cast iron, the modulus of elasticity is 100 gigapascal. I-illustrate natin ito. So given here in the problem, we have the diameter of the steel bar, which is equal to 50 mm. So this inside diameter here is equal to 50 mm. And the outside diameter here can be computed since given is the thickness. So since the thickness here is equal to 5 mm, ibig sabihin we have 5 mm here and 5 mm here, so that would give us the exterior diameter of 60 mm, and we denote this as the capital D, and the lowercase d naman itong interior diameter natin. So we are asked to find the compressive load P. So here we have the load P, and this load will be resisted by the force exerted by the cast iron, and of course the force resisted by the steel bar. So if we are going to summate force as vertical is equal to 0, taking the upward direction as positive, we have the downward P, so that's negative, plus the force resisted by the cast iron plus the force resisted by the steel bar is equal to 0. So this would give us the P is equal to force resisted by the cast iron plus force resisted by the steel, and this is our equation 1. Since from the definition of the statically indeterminate members, we have here 3 unknowns. We don't know what's the value of P, the PCI, and the PS. So here, since we have 3 number of unknowns and we only have 1 equation to be used, so we have 3 minus 2. This is statically indeterminate to the 2nd degree. That is just the difference between the unknown and the available equation to be used. So, hihingi tayo ng tulong from the relationship of the elastic deformation, the deformation in steel, and the deformation in cast iron. So, doon magkakaroon tayo ng dalawang equation. So, this 1 equation here plus 2 equation. So, mayroon na tayong 3 available equations to solve for the 3 unknowns. So, from the equation of the deformation, we have the deformation is equal to PL over AE. So, we know that the total deformation of this member, assuming na the same yung deformation ng dalawang to, So we have the deformation of the steel bar and the deformation of the cast iron is just equal to the given deformation in the problem, and that is equal to 0.8 mm. So this is 0.8 mm. And so we solve for the force resisted by the cast iron. So for cast iron, we have here the deformation of the cast iron is equal to PL over AE of the cast iron. So we have here the deformation is equal to 0.8 mm, and we have the P of the cast iron and the length. So given in the problem, the length is 2 meters. So we have here the length is equal to 2000 mm. So this is equal to 2000 mm. For the cross-sectional area, the cross-sectional area of the cast iron is this. Ito yung cross-sectional area ng cast iron. Now, we take this area as the difference ng area ng circle outside and inside the circle. So we have the area ng cast iron is equal to the area outside, so that's pi d square over 4 minus the area of the steel bar, which is pi d square over 4. So we have the area of the cast iron is equal to pi over 4 d square minus d square. So we have here pi over 4. The outside diameter here is 60 mm square minus the inside diameter, which is 50 mm square. Ilalagay ko na yung unit sa labas, and that's mm square. Multiplied by the modulus of elasticity given in the problem. The modulus of elasticity of the cast iron is 100 gigapascal. So in here we have 100 times 10 to the 3 megapascal. Now computing for the force resisted to the cast iron, we have 0.8 is equal to the unknown x times 2000 over, hindi na natin muna isasama si pi para yung sagot natin later ay merang pi. We have 60 square minus 50 square over 4 times the modulus of elasticity of 100 exponent of 3. Check solve equals, and we would have 11,000. So we have here 11,000 pi, and your unit here is Newton. Now for the steel bar, we have the deformation of the steel bar is equal to PL over AE of the steel bar. So we have here the deformation, which is equal to 0.8 mm. The force resisted by the steel bar, and the length is equal to 2000 mm over the area of the steel bar, that is pi, diameter is 50 mm square over 4, multiplied by the modulus of elasticity of the steel bar, that is equal to 200 gigapascal. So we have here 200 times 10 to the 3 megapascal. So solving for the force resisted by the steel bar, we have 0.8 is equal to x multiplied by the length, which is 2000 over hindi na natin isasama si pi, so that is 50 square over 4 multiplied by the modulus of elasticity, which is 200 exponent of 3. Shift solve equals, and that would give us 50,000 pi. So we have here 50,000 pi, and your unit here is Newton. Now, if we go back to our equation 1, we have here the total load that would compress the bar at the given deformation is equal to the force resisted by the cast iron plus the force resisted by the steel bar, and this is equal to 11,000 pi Newton plus 50,000 pi Newton. So we have here the total load B of 61,000 pi Newton, and this is our answer.